Hari Om. In this video we discuss perpendicular axis theorem. Now as you have seen parallel axis theorem, there was a situation there, the two parallel axes will be coming here. So when you hear about perpendicular axis theorem, you will be considering perpendicular axis here. Now how it is, we'll see. For that I consider a laminar body, a sheet-like body. Regular shape, no problem, but it must be of a sheet-like or laminar, we say. Okay? So, if you consider a laminar body, and if I want to find the moment of inertia of this laminar body about an axis passing through the body, okay, perpendicular to its plane, suppose. So this is the axis of rotation of the laminar body. Now if I want to find the moment of inertia about this particular axis, then I will be considering two axes. One is lying like this, and another one like this. So this you can consider to be the x-axis, and this can be y-axis, and this can be z-axis. Okay, this can be z-axis. So if I want to find the moment of inertia of the laminar body about this z-axis, then as per this perpendicular axis theorem, I am getting I z, moment of inertia of the body about the z-axis will be equal to Ix plus Iy. That means sum of the moment of inertia about x-axis and moment of inertia about the y-axis. So this is the mathematical form of what we call the perpendicular axis theorem. See, here we are getting three axes, all three are mutually perpendicular to each other. And the considered axes are lying on the plane of the lamina, and all the axes will be meeting at point O. Right? So these are the conditions. So how to define the perpendicular axis theorem? It's defined like this, that moment of inertia of a laminar body about an axis passing through the body perpendicular to its plane will be equal to sum of the moment of inertia of the laminar body about two axes lying on the plane of the lamina and passing through the same point, such that all the three axes are perpendicular to each other. Okay? So this is how we are defining the moment of inertia, perpendicular axis theorem. Now to have the idea about this one, I will give you a small derivation for this one. Suppose I consider a small mass over here, which is at distance r from the origin of the axis. Then moment of inertia of that mass delta I will be equal to m into r square. Okay, but this m into r square, I can get it like this, that this will be the, what do you call, y part, and this will be the x part. Alright, so this is x measure and this is y measure, and therefore I can get that r square can be written as m into x square plus y square. Pythagoras theorem. Okay? And therefore, the total moment of inertia of the whole lamina can be taken as sum over m into x square plus y square equals c. That means I equal to sum over m into x square plus sum over m into y square. Okay? But here remember m into x square, m into x square. This m and this x, if I say, actually you are defining the moment of inertia of the mass about y axis. Therefore, this will be nothing but equal to, this part will be I y equal, say, moment of inertia of the body about y axis, and this will be, when I say m into y square, that is m into this distance. So, okay, you are defining that with respect to x axis, therefore iy plus ix, or you will be getting I z is equal to, that is I, this I is about the given axis. Okay, so I z will be equal to ix plus iy, and this is a simple derivation you can have for perpendicular axis theorem. Okay, so simple to remember also. But remember one thing, laminar body and the given axis must be passing through the body perpendicular to its plane. It's must. Now let us see a small example for how to apply this perpendicular axis theorem. Right? For that, we will be considering a case that a ring of mass m and radius r, a ring of mass m and radius r, whose moment of inertia we consider. A ring and it's a ring of mass m and radius r. Okay. Now suppose I want to find the moment of inertia of the ring about its diameter axis. That means I want to find the moment of inertia of the ring about this particular axis. Okay. So if the ring rotates about this particular axis, what will be its moment of inertia? This is the question. Now as we know, we are taking an example for applying perpendicular axis theorem. Some of you might have got the idea how the perpendicular axes are coming. So I consider the first one, that is, we know the value of moment of inertia of the ring about an axis of its own, or passing through the center and perpendicular to its plane. Already know. So I consider one axis here. Okay? And one more axis is required, but will be like this. Alright? So altogether how many? 3 axes we have. So this is, let us say, x axis, and this is y axis, and this is z axis. Now 2 axes are are lying on the plane of the lamina, plane of the ring, and other one is passing through and perpendicular to its plane. Everything agreeing with the definition of perpendicular axis theorem. Now I write the perpendicular axis theorem that moment of inertia of the ring about z axis will be equal to moment of inertia of x with respect to x axis and plus moment of inertia of the ring with respect to y axis. But you see, x axis and y axis, you see that both are diameter axis. Okay? X axis and y axis are coming there as the diameter axis, and therefore the moment of inertia of the ring about any diameter axis will be the same if the mass distribution is uniform. So it is understood that we have taken a ring with the uniform mass distribution. So moment of inertia of ring about x axis and about y axis is same, and therefore I can write that Ix is equal to Iy. So I can substitute that as Iz is equal to 2Ix or 2Iy, and therefore Ix is equal to Iz divided by 2. This is what I am getting. But we know that the value of moment of inertia about its own axis will be, that is, Iz is already known, that it is mr square for the ring, and therefore Ix therefore will be equal to mr square by 2. So moment of inertia of the ring about a diameter axis will be equal to mr square by 2. Like this, you can take the case of disk. Of course, you can apply perpendicular axis theorem accordingly. Alright. So these are the two theorems here, like parallel axis theorem and perpendicular axis theorem. Okay, and you understood how to apply that theorem in finding the moment of inertia of the object also.